Manufacture of 40% Glyoxal based on oxidative dehydrogenation using silver catalyst. Abstract Glyoxal is provided generally as a 400th solution. It's oftentimes used for condensation and cross-linking reactions owing to the reactivity of its organic compound teams towards polyfunctional compounds with group or amino teams. With organic compound and its derivatives, or with starch, cellulose, cotton, casein, or animal product. It acts as a biologically active compound, inhibits corrosion, and aids in solidifying rubber and in animal skin tanning. Its associate intermediate within the preparation of dyes, prescription drugs, polymers and textile auxiliaries. Industrial Glyoxal is ready by either the gas section reaction of ethanediol within the presence of a silver or copper catalyst or by the liquid section reaction of ethanal with acid. The potential of manufacturing Glyoxal from the ethanediol is encouraging and may be explored particularly within the country with the high ethanediol productivity. Keywords: oxidation of ethylene glycol, condensation, and cross-linking reactions. Introduction. Glyoxal is associate in nursing compound with the statement OXIDA. It's the tiniest dialdehyde, a compound with two organic compound groups. Pure Glyoxal isn't usually encountered as a result of it forms hydrates, that oligomerize. For several functions, these hydrous oligomers behave equivalently to Glyoxal. It's made industrially as a precursor to several products. Glyoxal is provided generally as a 400th solution. Like different little aldehydes, Glyoxal forms hydrates. Moreover, the hydrates condense to relinquish. Structure of Glyoxal. A series of oligomers, a number of that stay of unsure structure. Glyoxal or ethanediol is often used for condensation and cross-linking reactions due to the reactivity of its organic compound teams towards polypurposeful compounds with chemical group or amino teams, e.g. with carbamide and its derivatives, or with starch, cellulose, cotton, casein, or mucilage. It acts as a biologically active compound, inhibits corrosion, and aids in solidification rubber and in animal skin tanning. Its associate in nursing intermediate within the preparation of dyes, prescription drugs, polymers and textile auxiliaries. Glyoxal, the only organic compound, was initially ready and named by the German-British chemist Heinrich de Buss, 1824–1915, by reacting ethyl alcohol with acid. The HNO3 technique remains used commercially, alongside metal-catalyzed gas phase oxidization of ethanediol. At low temperatures, Glyoxal forms yellow crystals. It melts at 15 AA degrees C and boils at 51 AA degrees C. Its low flash purpose, 4 AA degrees C, makes its inexperienced vapor explosive in air. It's used principally in paper coating and textile finishing processes. Industrial Glyoxal is ready either by the gas phase oxidization of ethanediol within the presence of a silver or copper catalyst or by the liquid phase oxidization of ethanal with acid. The primary industrial Glyoxal supply was in Le Mans, France, started in 1960. The only largest industrial supply is BASF in Ludwigshafen, Germany, at around 60,000 tons per. Different production sites exist additionally within the United States of America and China. Industrial bulk Glyoxal is created and reported as a 40% strength answer in water. Properties and applications: physical characteristics of Glyoxal such as boiling point, melting point, density, and chemical characteristics such as can affect the use of such substance and render its suitability for specific applications. Textile industry: physical characteristics of Glyoxal like boiling purpose, freezing point, density, and chemical characteristics like will have an effect on the utilization of such substance and render its quality for specific applications. Paper business: it's used as building block for cross-linker. It will increase paper wet strength, e.g. restroom paper. It will increase paper dry strength, e.g. recycled paper. It's used as economical paper coating additive for high-quality papers. Oil and gas business: it's used as H2S scavenger and cross-linking polymers, hydrocolloids. It's anti-corrosive, perishable, and it supports safety work. It improves body in oil drilling fluids. Leather business A. It's used as cross-linking agent in tanning method. It helps to preserve the animal skin quality. Methodology. The various process and technologies required for the manufacture of 40% Glyoxal are as follows. Oxidation of acetaldehyde to Glyoxal by nitric acid, the liquid section. Oxidization of aldehyde or aldehyde by binary compound acid to Glyoxal was investigated during a chrome steel autoclave maintained underneath autogenous pressure. The presence of acid was necessary for the reaction. Ethanoic acid and glyoxylic acid were the main byproducts. The results of concentration of acid, and aldehyde in addition as temperature and amount of reaction on the conversion and yield of Glyoxal were studied with a read to getting the four most appropriate conditions for the assembly of Glyoxal. Glyoxal from ozonolysis of benzene. Glyoxal is produced when benzene is treated with ozone in the presence of Zn/H2O. This process is called ozonolysis. Microbial catalysis of ethylene glycol to Glyoxal. The production of Glyoxal from Glycol has been incontestable with the utilization of glycerin enzyme and enzyme as catalyst from Aspergillus versicolor. Glycerin enzyme was fashioned within the mycelia of the fungi grown up on Glycol because the sole carbon supply. Enzyme activity is actually vital as CO catalyst to decompose byproduct oxide, therefore limiting peroxide-dependent methanolate production and glycerin enzyme deactivation. The initial strain of Aspergillus versicolor possess high glycerin enzyme and enzyme activities. Throughout additional screening of the enzymes, we've got found that glycerin enzyme from A versicolor change Glycol to Glyoxal. Enzymatic production of Glyoxal from ethylene glycol using alcohol oxidase from methanol yeast. A new oxidative reaction of ethylene glycol was found with two alcohol oxidases from methanol yeast, Candida boydonii and Pichia pastoris. Both alcohol oxidases oxidize ethylene glycol to Glyoxal via glycol aldehyde. These alcohol oxidases were specific for short-chain linear aliphatic alcohols such as methanol, ethanol, N-propanol, and N-butanol, which were oxidized to the respective aldehydes, formaldehyde, acetaldehyde, propionaldehyde, and butyraldehyde. Glyoxal by oxidative dehydrogenation using silver catalyst. Glyoxal was obtained by the oxidative dehydrogenation of ethylene glycol. After a series of experiments, it was found that the best reaction conditions obtained at a residual pressure of 400 to 600 mm with the use of a silver catalyst in the form of spirals. A mixture of the vapor of 40% aqueous ethylene glycol, 0.78 mol/H, and a 1:1 air nitrogen mixture was passed through the previously described reactor containing 7 ml of catalyst. The air was passed at a rate of 180 liters/H. Oxygen was therefore taken in 150% of the theoretical amount. The condensate contains 0.25 g/ml of Glyoxal, 2, which corresponds to a yield of 63.2%. Process selection. Of all the feasible processes available for the manufacture of Glyoxal, oxidative dehydrogenation using silver catalyst method is selected. The process selection criteria are: Glyoxal was obtained by the aerophilous dehydrogenation of glycol. Once a series of experiments it absolutely was found that the simplest reaction conditions obtained at a residual pressure of 400 to 600 mm with the utilization of a silver catalyst within the variety of spirals. A combination of the vapor of four-hundredth binary compound glycol, 0.78 mol/H, and a 1:1 air nitrogen mixture was knowledgeable. The Anil represented reactor containing 7 metric capacity unit of catalyst. The air was passed at a rate of 180 liters/H. Atomic number 8 was thus taken in 150th of the theoretical quantity. The atmospheric phenomenon contains 0.25 g/ml of Glyoxal, 2, that corresponds to a yield of 63.2%. Technique involves vapor phase chemical process, chemical change, chemical action process of partial aerophilous dehydrogenation of glycol with atomic number 8 diluted with steam and gas within the mole magnitude relation from 1/6.5 to 1/13.0 at temperature 4007008 degrees C on carrier Ag contacts and big Ag catalysts fabricated from materials of electrolytic origin of particle size 0.1 to 4.0 mm. Then the method involves continuous the VAT-less separation of vapor gaseous oxidate for liquid fractions and vaporific part whereby ready binary compound organic compound solutions contain 4 to 40% of glyoxal, 6.2% of glycolic organic compound, not above, 4.6% of gas, not above, 4.0% of glycol, not above. At the entire acidity index, a pair of the top product contains 39.8% of glyoxal, 5.5% of glycolic organic compound and 0.4% of gas. The method of continuous the VAT-less separation of synthesis merchandise for glyoxal containing liquid fractions and depleted vaporific part is meted out unceasingly within the vary of temperature 1040088 degrees C as results of subcontact cooling together with three-step combined condensation of parts of vapor gaseous oxidate in a very cascade block unit in fragmental isolation of liquid and vaporific merchandise of synthesis, and in regulation of warmth program of the combined condensation and alter of magnitude relation of the technique of manufacturing glyoxal by reaction of glycol with atmospherically atomic number 8 in a very mixture with recirculating argon on a catalyst containing silver. Recirculating gas used as an agent and glycol resolution coming into reactor square measure in turn preheated by heat generated throughout reaction of glycol at catalyst, and cooling of reaction merchandise is performed in turn by their irrigation with cooled resolution of glyoxal in a very zone lying like a shot behind catalyst layer and in cannular subcontact two-sectional device. In lower section of that glycol is heated, and within the higher section heating of the recirculating gas used as an agent. Material of construction. Materials of construction square measure sometimes designated supported their strength, elasticity, hardness, toughness, sensitive to wear, corrosion and fatigue resistance, simple fabrication, availableness, worth, and value price. Metals square measure sometimes characterized on the premise of their chemical and physical properties within the solid state. Several factors need to be thought about once choosing engineering materials. Except for natural action plant, the predominant thought is typically the power to resist corrosion. The method designer is liable for recommending materials which will be appropriate for the method conditions. Chemicals, however, conjointly to supply them safely. Within the plant's chain of processes and operations, loss of management any place will cause accidents, then losses of life and property from hazards. Tries ought to be created to forestall troubles from the review, whereas planning, fabricating and operational safety usually involves instrumentation and process control. Instruments are providing to observe the key method variables throughout plant operation. They'll be incorporated in automatic management loops or used for the manual observance of the method operation. They'll even be a part of an automatic laptop information work system. Instruments observance. Crucial method variables are fitted with automatic alarms to alert the operators to crucial and dangerous things. Instrumentation and management include the subsequent: plant location and layout. The geographical location of the ultimate plant will have sturdy influence on the success of an industrial venture. Considerable care should be exercised in choosing the plant website, and plenty of various factors should be thought about for the plant came upon. Plant location depends upon the subsequent factors. After the method flow diagram square measure completed and before careful piping, structural, and electrical style will begin, the layout of method units in an exceedingly plant and therefore the instrumentality among these method units should be planned. This layout will play a crucial half in decisive construction and producing prices, and therefore should be planned fastidiously. Some necessary factors that square measure to be thought about. Square measure. Cost estimation. Evaluation of costs in the preliminary design phase is sometimes called guess estimations. A plant design obviously must present a process that is capable of operating under condition which will yield a profit. Estimation of plant cost. This chapter includes the detailed study of cost calculations done for the whole plant and finding the rate of return per annum based on 40% Glyoxal sales. Conclusion. The main objective of the paper is to supply the 400th Glyoxal from Glycol in presence of air/N2 mixture in autoclave batch reactor mistreatment silver spirals catalyst. 400th Glyoxal is employed in big variety of applications thanks to its distinctive properties. The method of manufacture of 400th Glyoxal from Glycol by vapor section aerobic dehydrogenation is studied. Material and energy balance are distributed for the plant taking 60,000 TPA production. The planning for every instrumentation is distributed and therefore the materials of construction area unit instructed. Because the chemical change involves safety as a very important facet, study concerning safety and varied controllers is completed. Plant location is recommended supported the material availableness and transportation because the necessary criteria and therefore the plant layout is recommended. The whole value to set up the plant is calculated and therefore the payout time and rate of cum area unit calculated. Acknowledgement. I would like to express my profound sense of gratitude to guide Mr. M. Sreenivas, Assistant Professor, Department of Petroleum Engineering and Petrochemical Engineering, Jaintuk, Kakinada, for their skillful guidance, timely suggestions, and encouragement in completing this paper.